Hello viewers, in today's class we are going to solve some important problems based on vectors. So the first problem is if vector A, vector B and vector C are unit vectors such that the sum of the three vectors is equal to 0 vector, find the value of this expression, right? So here vector A dot vector B plus vector B dot vector C plus vector C dot vector A. Now here we will make use of a very important result in vector algebra, that is square of a vector is equal to the square of its magnitude, right? Now here what we will do, we will consider this vector, right? Vector A plus vector B plus vector C, this vector will be considered and the square of this vector is taken, right? Now this square of this vector can be written as the square of the magnitude of this vector. So here we can write the magnitude of vector A plus vector B plus vector C square, right? Now this can be written as vector A plus vector B plus vector C dot vector A plus vector B plus vector C, right? Because we know that if we have two vectors, A dot B is equal to mod of vector A mod of vector B, or the magnitude of vector A magnitude of vector B and cosine of theta, right? And since if the two vectors are equal, then vector A dot vector A can be written as cos 0 degree, right? So this can be written as vector A dot vector A can be written as vector A square, and here cosine of 0 is 1, so we have the magnitude of vector A square, right? So magnitude of vector A square is equal to A dot A. So here the square of the magnitude of vector A plus vector B plus vector C can be written as vector A plus vector B plus vector C dot vector A plus vector B plus vector C. Now we will take the dot product of these two vectors, and here we have A dot A plus A dot B. Taking the dot product of vector A with this vector, we have A dot C, right? Similarly, we have B dot A plus B dot B plus B dot C, right? Now we have C dot A, then we have C dot B, and then we have C dot C, right? Now here A dot A is written as magnitude of square of the magnitude of vector A, then we have vector B dot vector B can be written as vector square of the magnitude of vector B. Then we have here C dot vector C dot vector C. This can be written as square of the magnitude of vector C, and plus A dot B. See, here we have A dot B, here we have B dot A. So A dot B is equal to A dot B, B dot A, because the dot product is commutative, so we have 2 times of A dot B, right? Similarly here A dot C, here we have C dot A, so this can be written as 2 times of A dot C, right? And here we have B dot C, here also we have B dot C, so this can be written as 2 times of B dot C, right? Now since vector A, vector B and vector C are unit vectors, so the magnitude of vector A is 1, magnitude of vector B is 1 and magnitude of vector C is 1. So this is equal to 1 square plus 1 square plus 1 square, and here we take 2 common, so we have A dot B plus A dot C plus B dot C, right? Now this is equal to 3 plus 2 times of A dot B plus A dot C plus B dot C, right? Now the sum of vector A plus vector B plus vector C is given as 0 vector, so here we have the square of 0 vector, which is equal to 0, right? So taking 3 to this side, we have minus 3 is equal to 2 times of vector A dot vector B plus vector B dot, taking writing this term here, B dot C plus, then we have C dot A, because A dot C is equal to C dot A, and taking this 2 to the denominator of minus 3, we get A dot B plus B dot C plus C dot A is equal to minus 3 by 2. So the value of this expression is equal to minus 3 by 2, right? So viewers, this is how we solve this problem. Now let us take this problem. Show that the vectors 2i cap minus j cap plus k cap and I cap minus 3j cap minus 5k cap and 3i cap minus 4j cap minus 4k cap form the vertices of a right angled triangle. So here we have to prove that the points, see here we have 2, here we have minus 1 and here we have 1. So 2 comma minus 1 and 1 is the vertex A, and here we have 1, here we 1 comma minus 3 comma minus 5, and here we have 3 minus 4 and minus 4. So we have to prove that these three vertices form a right angled triangle. So here I have not drawn directly a right angled triangle, but we will prove it and then we will again draw the diagram of the triangle, right? So for this, what we will do, we will find the vectors AB and then vector BC and then vector CA, right? So let us find the vector AB. Now AB can be written as vector OB minus vector OA. BC vector can be written as vector OC minus vector OB, and CA can be written as vector OA minus vector OC. Now here O is some reference point, right? And these are the position vectors, right? So OB, the vector OB is given as, because this is vector OA, this is vector OB, and this is vector OC, right? Now if we substitute here, we can find out vector OB minus vector OA gives us minus I, and then we have minus 2j, and then we have minus 6k, right? Similarly, we have OC minus OB. OC minus OB is 3 minus 1, that is 2 I cap, minus 4 plus 3 minus j cap, minus 4 plus 5, that is k cap. And vector CA can be written as A minus C. So we have 2 minus 3, that is minus I cap, minus 1 plus 4, that is 3j cap, and 1 plus 4, that is 5k cap, right? Now we will find the magnitude of these three vectors, right? Now we will find the magnitudes, and the magnitude is given by square root of minus 1 square minus 2 square plus minus 6 square, right? Here in case of vector BC, we have 2 square plus minus 1 square, then we have 1 square, and here we have minus 1 square plus 3 square plus 5 square. Now if we simplify, then we have 36 plus 4, that is 40, and 41, square root of 41. Here we have 4 plus 1 5 plus 1 6, and here we have 25 plus 9, that is 34 plus 1 35, right? Now viewers, we know that a triangle is said to be a right angle triangle if one angle is 90 degrees and it satisfies the Pythagoras theorem, right? So here we see that the square of the magnitude of BC plus square of the magnitude of vector CA is square root of 6 square plus this is square root of 35 square, and this is 6 plus 35, and this is equal to 41, and 41 is equal to the square of the magnitude of vector AB. So viewers, we have shown that here we have a triangle which satisfies the Pythagoras theorem, and here we have 41, here we have 41, here we have 6, right? Here we have a square root of 41, here we have a square root of 6, here we have a square root of 35, right? And we can have and here we have the vertices A, B and C, and now we have to show that this angle, that is angle ACB, is of 90 degrees, and for this what we will do, we will find the dot product of vector AC and BC, right? Because we know that if the dot product of two vectors is 0, A dot B is 0 when theta is 90 degrees, right? So here we will find the vector product, the scalar product of vector AC and vector BC, right? So what is vector AC? AC is minus I cap. Here we can write AC as here AC can be written as I cap, because C we have here a CA vector. So AC vector is negative of CA vector, so we have I cap minus 3j cap and minus 5k cap, and we have to take the dot product with vector BC, and vector BC is 2i cap minus j cap plus k cap. Now the dot product is, here we have 1, so 1 into 2, and then we have minus 3 here, and here we have minus 1, then we have here minus 5, and here we have 1, right? So this is 2 ones are 2, here we have plus minus minus plus, we have 3, and here we have minus 5, so this is 5 minus 5 is equal to 0. So the dot product of these two vectors is 0, hence this angle is angle ACB is 90 degrees, right? So therefore we have proved that these vertices form a right angled triangle. Now let us take this problem. Here we have to show that the cross product, the vector product of these two vectors is equal to 2 times the vector product of vector A and vector B. So what we will do, here we will take the left hand side. Here we have vector A minus vector B cross vector A plus vector B. Now taking the cross product, we have vector A cross, we have vector A plus vector B, then we have minus B cross, here we have vector A plus vector B, then we have A cross A plus A cross B, then we have minus B cross A minus B cross B, right? Now viewers, here this is equal to 0, this is also equal to 0, because if we have the cross product of same vectors, it is vector 0, right? So this is 0 vector, so we have 0 vector plus vector A cross vector B, and this is plus A cross B. Why? Because A cross B is equal to minus of B cross A, and here we have 0 vector. So this is 0 vector, this is 0 vector, and here we have A cross B plus A cross B, and this is equal to 2 times of A cross B, and it is equal to right hand side, right? Now come to this problem. Find the value of x for which we have this vector is a unit vector. So let vector A is equal to x times vector I cap plus j cap plus k cap, right? Now this can be written as xi cap plus xj cap plus xk cap, right? Now we have to find the value of x for which this is a unit vector. So it means the magnitude of vector A should be 1. And what is the magnitude of vector A? Vector A is given by this vector, so we have square root of x square plus x square plus x square is equal to 1, and this can be written as square root of 3x square equal to 1. This can be written as x square root 3 is equal to 1, and x is equal to here we have plus minus 1, so x is plus minus 1 over square root of 3, right? So the value of x is plus minus 1 divided by square root of 3. Now come to this problem. We have to prove that vector A plus vector B dot vector A plus vector B is equal to square of the magnitude of vector A plus square of the magnitude of vector B if and only if vector A and vector B are perpendicular, right? And here we are given that vector A and vector B are not equal to the 0 vectors, right? Okay, now if we take this side, that is the left hand side, we have vector A plus vector B dot vector A plus vector B, and now if we take the dot product of these two vectors, we have vector A dot vector A plus vector B, and then we have vector B dot vector A plus vector B, and A dot A, that is vector A dot vector A plus vector A dot vector B, plus vector B dot vector A plus vector B dot vector B. Now here vector A dot vector A is the square of the magnitude of vector A, and then A dot B is 0, B dot A is also 0, and here we have vector square of the magnitude of vector B, and this is equal to square of magnitude of vector A plus square of the magnitude of vector B, right? Now here A dot B is equal to magnitude of A, magnitude of B cos theta. Now here we are given that this expression is true if and only if vector A and vector B are perpendicular. So when theta is pi by 2, then cos pi by 2 is 0. So therefore vector A dot vector B is 0, and similarly vector B dot vector A is also 0. So therefore we have proved that the dot product of these two vectors is equal to the square of magnitude of A vector plus square of magnitude of vector B, right?